some of the first success stories are additive manufacturing on the space station, where, they were testing, all right, if we need to get something up to the space station, how much is it going to cost? And if they don't have it today and they need it today, what do they do? So they put a test printer up there, and they were able to send files back and forth, and it exaggerated the need because it's very expensive and time consuming to get to space, right? And apply that to the DoD, depending on where the point of need is, it's important. We supported the Army through one of their programs called RFAST, where they explored these possibilities, and they took a complete set of capabilities, a machining center, a water jet, press brakes, some 3D printers, and moved it to Bagram Air Base, and then supported it with Army engineers. So they would go on 6-month rotations, and they would go out to Bagram, and if the soldier needed something to complete their mission, rather than sending that information back to the States and working on a solution there, they would converse with the States and then produce the part at Bagram. So now you're moving the solution closer to the point of need. And that's really what the mobile shop set is doing as well, albeit through traditional manufacturing. And now we're exploring possibilities of incorporating additive into that capability.
Yeah.
We still have a lot to address with obsolete parts, the workforce, and new and novel designs, which is neat.
So
I'll share with you.
I was going to say, speaking of that, you've got some great things to show us.
Yeah, I wanted to share a part. One of the technologies we plan on putting at the Rock Island facility is a company called Speed 3D. And it's a cold spray technology that allows you to produce a near net shaped part very quickly. And I'm not sure if you can see this, but this happens to be a battery terminal off a Humvee.
Yeah, I can see it.
Andy would probably recognize this, but if this breaks, the supply chain for that is typical supply chain. If you had access to a Speed 3D, you could make this part in 6 minutes.
Wow.
So it's pretty neat to see that you have the capability of accelerating manufacturing at point of need. You can send that digital file or reverse engineer it, print it very quickly, and have a fix. Now, will this replace an OEM part? I don't know, but it could get the soldier and the vehicle to the next point or maintenance interval to replace it with an OEM part.
Yeah. Oh, wow. Could you show us some of the other things as well that you've got there?
Yeah, so I'll start with something. This is an Under Armour shoe, and EOS is one of our key partners. They're a leader in powder bed fusion technology in metal and plastic. And if you look at the heel of it, it's a design that's kind of unique. And typically, manufacturers will make a foam mold or some type of cushion. This happens to be an engineered or digital foam. And what that does is allow you to customize the cushion or the firmness specific to an athlete. This is another example of digital foam. So this is just a football, and you see a matrix of parts in there, and you can sort of squeeze it, even though it's made out of plastic. The matrix is what defines it, and you can optimize the matrix through software. So whatever you can imagine, you can print. These are some of the smaller examples. Let's get to one that's a little more relevant right now. We just had our first launch of a spacecraft off U.S. soil. So let me go back and grab one of the bigger parts.
Okay.
So this happens to be a 1 meter tall rocket engine part by a company called Launcher. And they currently have an SBIR with the Air Force to test fire a copper version of this to put satellites into space. But when we talk about what SpaceX is doing, their engines have 3D printed components made on EOS technology that helped America get back into the launching game. And it's pretty interesting to think about how rocket engines were traditionally made with multiple layers to incorporate internal cooling channels. With a 3D printer, you can incorporate all those internal cooling channels in one build, and it makes the manufacturing process a lot more efficient.
Wow.
So we're kind of proud of this part.
Yeah.
It's one of the tallest printed powder bed fusion parts in the world. And this one was printed, I think, 2 or 3 years ago. So we've been doing it for a little bit. EOS is going to be one of the partners at our innovation center. We're going to have a metal printer from them.